Let's prove a theorem and see if we can use all the ideas of geometry and apply them in some sort of neat, clever way. You know, the hard part about proving these things is that we have to think of the clever ideas to actually employ that utilize all the material that we've been learning about. So that's why these proofs are so exciting and challenging. Anyway, let's take a look at our given. Y, we're told, is the midpoint of the segment XZ. So that point is the midpoint. Okay, good, we'll remember that. And then we know that angle XYW is a right angle. So I'm going to mark that right here using a little right angle notation. And that's all we know. And now we're supposed to prove that angle XWY, so that angle right there, is congruent to angle ZWY. So these angles are congruent. That's what we're trying to show. Boy, we don't know a lot of stuff, so what should we do? Well, we need to look at it and realize, well, first of all, I noticed that since these two angles actually lie on the same line, then these are supplementary angles, which means the sum of these angles equals 180 degrees. I know this angle is already 90, and so if I subtract 180 minus 90, I see this angle must be 90. Great, so that's 90, I can mark that. That wasn't given, that followed from the given. We actually proved that. Okay, so I see that these two angles actually are congruent. What else do I know? Well, remember that we're told that y is the midpoint of this segment. By definition of midpoint, it means that it divides up this segment into two segments having the same length. And therefore, these two line segments, xy, is congruent to the line segment zy. So I can mark that like this. Hey, now I'm making great progress because I see side angle are congruent. Can I get one more? Well, look, this side of the left triangle is also a side of the right triangle, and yet it's the exact same line segment. So by the reflexive property, I know that WY is congruent to itself, and so therefore, these two sides, this common side that they both share, in fact, is congruent to itself, and so I've got side, angle, side, congruent. Side, angle, side. Therefore, we see that these two triangles are congruent by side, angle, side. That's not what we were asked to prove, though. But once we know that the triangles are congruent, we know that corresponding parts will be congruent. So, notice that these two angles are corresponding angles because they both lie on the opposite of the green-marked sides. Therefore, these two angles are corresponding. Since the triangles are congruent, we know for sure that this angle is congruent to this angle, and we just proved the theorem. Utterly awesome. Congratulations.